Hey everyone. So I'm going to try something a little bit different here. We're going to be talking about lighting this week, and lighting in Unity has always been one of the more, I don't want to say like complicated things. There's just there's a lot of fundamental concepts that for me coming into this as an audio composition based person seemed really foreign, difficult for me to wrap my head around. So what I wanted to do was like literally just kind of record what we're going to do in class on Wednesday of this week. Um, because frankly, I want to walk through it with you before I walk through it with you, if that makes sense. I like to teach it before I teach it. To help myself kind of wrap my head around it, but also have this be sort of a template for maybe something we could do in the future, creating a resource for you to go to that's more or less the lecture, if that makes sense, as opposed to more of a guided, sort of assignment-based thing, like I've been doing for your assignments. So, anyways, we're going to talk about lighting today and just the fundamental concepts of lighting in Unity. So what we're going to do, we're going to pull in something that's called a Cornell Box. And I'll provide a link to this for you for class. But I've already brought it in here. And this is a prefab that I made that's based on, well, it's not based on, it literally is what's called a Cornell Box. It was developed at Cornell University as a way to begin to see if we can create digital representations of actual literal lighting. So what they did was they made this in reality, this little cube kind of looks like this, and then created that in a computer to try and match the qualities, right? To see if they can light the literal thing and then slowly over time get to something that's a computer generated representation of that. And obviously we've made things that are photorealistic in computing. We are looking at this as a template because it's going to serve as sort of the backdrop for talking about some of the fundamental concepts of lighting in Unity. So all I did was I grabbed this this Cornell box and dragged it into my hierarchy, just making sure that it is set up at 0, 0, 0. So we're at the origin here. And then just to quickly look through the prefab here, if you open it up here, I have this game object here called lights, and underneath that there's a point light. We're going to talk about point lights quite a bit. Then we have this thing that's called box, and this is just the prefab I made with all the different walls. So you have all the different walls, and the right wall and the left wall are red and green. And then this thing says objects. It's just the back and front cube. And these ones are just boxes with these materials called front box, back box. Okay, so right now this looks really kind of strange. And that's because of how the lighting is defaulting in our scene. So a couple things I want to do to get us to like tabula rasa, right? We want to get to just a neutral world where we can talk about the concept of lighting. So I'm going to disable a few things. I'm going to disable the directional light like that. And immediately that took the sun out. So that, changed a lot of things. Mainly you don't have shadows at all. I'm also going to disable this point light here for now. And now we are at black, right? The other thing I want to do, and this is an important concept here, I've been clicking on light game objects. Directional light is a light and has the light component on it. Point light is a light and has the light component on it. I'm going to go over and click on lighting now. So this is a different thing. So you control a lot of the light principles and properties on the actual game objects. But if you want to control global lighting settings, you have to go to lighting, the actual lighting window. And if you don't have that in your setup, you go to window rendering and then light settings, and it'll come up over here. You can dock it wherever you want. So in here, there's a couple of interesting things here. The first thing I'm going to do is I'm going to turn intensity multiplier down to 0 for environment or lighting. And the reason is, and also this one down, reflections down. The reason is what this is controlling is the actual light we're getting from the sky. And we have this like procedural skybox that you guys have seen before, right? I don't want any of that. I don't want Unity to try to imply that like the sky is giving us any kind of light data. I want to control all of it at the micro level here. So just turn those down. We'll play with that later. And then what I want you to do is scroll all the way down here to where it says, I'm going to move my face here, to where it says generate lighting, and click OK. So that's not going to do anything because there's no lighting data in our scene. We're going to be doing a lot of what's called light baking when we talk about light. So you'll see my computer do that, and it's going to go at a very different speed than yours. I have a pretty beefy development PC for VR. Your light bake might take a long time, and that's okay. Just let it go. It entirely has to do with the amount of cores and the core frequency that you have in your PC, laptop, whatever. If it seems like it's taking a while, just let it go. Especially the first time you bake light in a new project, it's going to take a little bit longer. So, just let it chill and go. And don't get frustrated. Just, let it do its thing. So I hit generate lighting, nothing happened. If by chance also this has auto generate clicked on, click that off. You don't want that checked. Otherwise, it's going to try to generate lighting every time you move an object in your scene, which is insane. Okay, so we have 0 light data right now. I want to go ahead and turn on the point light again. Okay, now you get this, which looks very artificial, right? This is just like the concept of light. Really quickly about point lights. Point lights are like a little ball of light. I like to think of it. It's like you have a little ball there that emits light. It's light coming from a point and emanating out in every direction. And the relevant data on this right now is the range of that light and the color of that light and the mode. So right now we have a range of 10. You can make that bigger. All that's going to do really is appear as if it's making it brighter. It's not. That what it's doing is, I'm going to set this back to 10. It's not making it brighter. It's just making the object, like the actual range, bigger, right? So the intensity from the middle is larger, right? So the objects that are really close to the light are going to appear as if they're being lit more brightly. If you actually wanted to change the intensity, that would be this, right? And you can get some really washed out kind of things very quickly. But we'll leave that at 1 for right now. Then the color, obviously you can change this and get some really kind of sort of trippy stuff. Let's leave that at white just for now. Again, we'll play with this later. And then the mode. And this is what we want to talk the most about, because I think these, for me, were the most confusing aspects of lighting when I first started this. So right now, we're in what's called real-time lighting mode, which is, much like it sounds like, everything that's being, every lighting calculation is being calculated in real time. It means every frame of your game, the CPU and the GPU are calculating the light, which is great, right? That's going to allow us to do things, like have accurate shadowing. And to that end, also, we don't have any shadows here. So let's click on shadows and go to soft here. And now we have shadows, right? This light is now allowing objects to cast shadows. And you can move the light around and have the shadows update. And this is the benefit of real-time lighting, right? That this is being calculated like this, and you could set up some sort of script if you wanted to that, like, did this, right? And it would cause the light to flicker. And that would be useful maybe, like, I don't know, if you had like a strobe light or something in your game. You could do this while playing with the intensity and playing with the color and script, and you could create this kind of effect. But that's only possible in a real-time setting where that's calculated every instance, right? Every frame, I guess. Which is super powerful. However, it's extraordinarily CPU intensive. And the problem with it is it's not particularly accurate. So take a look at this. Like, this looks weird. I mean, it looks like video gamey, but it doesn't look right. It doesn't look real, right? Because light doesn't do this, actually. Light doesn't hit an object and then create a void behind it. Like, the shadow is infinitely dark, right? That's insane. That's not actually how the world works, right? The way that light behaves, right, is light is emitted from a source, like a light bulb or something. And then the light rays are bouncing around the room, right? They're going, from the light source, hitting the wall. And then once they hit the wall, they sort of like reflect or bounce or sort of like grab. You can think of it like this, like they grab data from that object that they hit, the wall, in this case, say the green wall. They grab some of the color data, they grab the reflectivity of it, and they bounce. The lights bounce and ricochet and hit another object, and they bounce around, obviously extraordinarily quickly and a lot. And at some point they hit our eyes, and that's how we see. That's how you interpret the world around you. And this is happening, obviously, nonstop. That is not happening here. What's happening is the light is hitting this cube and stopping. And it's not bouncing. It's not creating any kind of like immersive, what we call bounced lighting. The only way in Unity 2019.4 that you can create bounce lighting is to use a different mode of lighting. And those are mixed or baked. And we're going to look at baked first. You click on baked, nothing happens here. Okay. The reason is you have to bake the lighting. What you have to do is you have to actually bake in light data, and you create what's called a light map. And this is what it's like literally doing, is drawing the light onto the objects. So it's like Unity is like painting where the light data, the reflections and the shadows, it's like drawing it onto these objects. So it would draw the shadow here, right? The benefit of that is it's drawn on. It's like literally just a picture. So it's not calculating that all the time, which means it's way more performative. In fact, it's like, it's great. It's like infinitely performative, right? You render it once, as opposed to the real time where you render it over and over and over again. The downside is you can't interact with it, right? Once you bake the light is there. The shadow is on that wall. So if we hit bake, right, or generate lighting, sorry, is when I say bake, like bake the light, I mean generate the lighting. Hit generate lighting. That's what you get. Okay, so what happened, right? Where'd the light go, right? The problem is, in Unity, in order for something to receive baked lighting data, that object must be marked static. You have to tell Unity that the object that you are baking is in no way dynamic. It is not going to move, which makes sense, right? It's the engine wants to be sure that when it casts light and it calculates all this stuff, right, that thing's not going to move around, because if it did, it would look really weird. And I'll show you how we do that, and you're gonna see really quickly. So what I want to do is tell Unity that the box, like the Cornell box, the outer box, and then the objects are static. They're not going to move. Right now, up until this point, unless you've jumped ahead and done this by yourself, you've only been using dynamic objects, which are great. It means they can interact with physics and do all this stuff. However, a lot of the stuff you want to use in your games is going to be static because it's going to save a lot of resources. So the way we do that is go into Inspector. You can click on the parent object, or you can click individually on all of these. It doesn't matter. But if you click on just box and then go up here, you can click this button up here that says static. If you click the little arrow down here, it's going to give you a whole bunch of stuff here. For us right now, because doesn't really matter, you can just hit the button and it's going to make everything static. And really, actually, for most of this class, I think that'll be fine. You say, yeah, we want to be static. Yes, we want to change the children because we want it to actually affect all of the children. Hit yes, and nothing happened. Go to objects, same thing. Click static, yes, change the children. Nothing happened. But now we go to lighting and we hit generate lighting. You see this, it says 13 minutes and it's like skipping really fast, right? 5 minutes. And this is where yours might take a while. So just let it chill and do its thing. It's building the light map. Again, I have a 16 core like development PC for doing stuff like this. If you're using like a MacBook or something with a quad core or dual core CPU, this might take 15 minutes. So just chill, let it go. It's done. Okay, so look at this. That is like so much more interesting. Interesting is the wrong word. It's more realistic looking. It looks like reality, right? Things to highlight. One, the shadows, right? These are not infinitely black. They kind of look like shadows now, right? Light's hitting this, it's bouncing, and you get some like gray area back here. because there's actually light obviously going over the box or hitting here and coming down. The most important thing to recognize here, though, one, if you change your light, nothing's going to happen. Okay, the lighting is set. This is baked. So this light that we had, this point light, is no longer dynamic. So we can't do anything to it. You move it around, nothing's going to happen. We've literally drawn these textures on these objects. Okay. The other thing is, if you move an object, that's what happens. So Unity has like created this thing, right? A picture, basically. Save computation data and also increase the fidelity of it. And the third thing, and this is really like, aside from the shadowing and just like general quality of it, you start to get what's called bounce lighting. Bounce lighting is that idea that like when you have light rays that hit stuff, right? They're hitting the walls, they gather data, and that like data is then brought onto another object when that light hits, and it bounces and bounces and bounces. And you may have heard about this if you follow gaming at all. In the last 2 years, there's just NVIDIA has come out with this new technology called RTX, or real-time ray tracing. And what this is the ability for this concept that we're talking about to happen in real time. So you can create real-time bounced lighting. And that bounced lighting for our Cornell box is here. Look at this box here. Like, this is green, right? This was gray. And if we went back to the real-time lighting, this was gray. It was white. What's happening now is the point light here is casting light on the wall. And that light is bouncing and hitting the box. And that, it's something you don't really notice because it's the way the world works. And you can see it here. It's a little more subtle with this one because it's further away from the wall and it's further from the light source. But this is pink. That box is pink, right? Because it's receiving red data from the light hitting the red wall and bouncing off and hitting this. Again, it's something you don't really think about too much in reality, but it's incredibly important for immersion. Again, this is something you want to be doing when we're building our scenes in the future, especially for VR, because you want to kind of shave as much computation off as possible, because your headset is trying to run, you know, at 80 frames per second at 2K, which is, you know, pretty fast, right? You're going to get some pretty good performance out of that. So you want to do stuff like this to allow for that performance boost. That is bounce lighting, baked lighting. You can only do that with baked lighting. The other option is to switch this to the third mode, which is mixed. And what this does is it allows for both. So you can get, if we go to lighting and hit generate, it should look relatively the same. But it allows for you to have some dynamic stuff with it. And this would be useful for something like, well, like a real-time light would be useful for something like a flashlight, right? Where you're looking around and you're holding it and you're shining it on things. You're not going to notice if that flashlight is creating bounced like illumination with objects. This might be for like if you had a lamp maybe in a room, right? You want there to be that sort of ambient accurate feeling when you walk into a room, that you get this kind of thing, but you also still want to be able to get some shadowing like this. And specifically, like say this is a lamp, right? There was a lamp sitting right here. You would want your character to be able to walk by the lamp and have a shadow. If you used a baked light, you wouldn't get that at all. If you used a real-time light, you would get the shadow, but you wouldn't get any of the baked, like global illumination, like this sort of thing here, where you get the bouncing. The mixed lights are okay. They're really not super performative. So, from my experience, and this is, you know, learning how to do this on the fly by jumping in and just making VR over the last 3 years, you don't want a lot of them. Like a few is probably fine. I ran into a problem where I didn't really realize that this was going to be a problem. I had a scene that I had made with like 40 mixed lights. And it was terrible, right? It ran at like 50 FPS and you throw your headset on and you want to vomit because like it can't render it correctly and it's all jittery and it doesn't feel immersive. So you want to find a balance, right? You want to The lights maybe that are like in the background that are lighting something, just bake them. Especially if you don't think your character is ever going to interact with that light, just bake it, right? If you have light casting on like mountains in the background or something, bake it. You're never going to interact with it. If you have a flashlight for some reason in your game, real time, right? Because you have to be able to interact with it. If you have a lamp that's sitting there, yeah, that's probably a good case for a mixed light, maybe. But you want to be really judicious with it, okay? Couple of things to note here that we have not talked about, and we'll talk about more of this in class, and this will be probably the end of this video because it's just the basic concepts. We didn't talk about light map settings. We're probably not going to. You don't have to mess with this stuff. The one thing you might want to experiment with is this, the light mapper. If you have if you have like an eGPU somehow, like you're running a MacBook with like a box next to it. I'm not sure if you guys do that, but you can then tap into a GPU for your light baking. If you have a more powerful GPU than a CPU somehow, and this is probably maybe true on like a laptop, if you have like a gaming laptop or something, then you can try this. What this will do is it'll offload the computation for your light baking to your GPU. This is multiplicatively more powerful. They're just way more powerful than CPUs. The downside is this is still in preview. It's kind of buggy, is the reason why I'm not having all of you use it. It's like, I can't explain it. Like if you do it, you'll see like sometimes it bugs out and doesn't work quite right. But if you want to try it, go for it. Especially if you know like your internals or something, that might be better. If you're using just like a standard like MacBook or something, you're going to be fine with the progressive CPU because you probably don't have a discrete graphics card. If you're on a desktop tower and you know you have like a gaming graphics card, try it, see what happens. But if you don't want to mess around with buggy stuff, just hang with the progressive CPU. Yeah, so we're not going to talk about most of that stuff. We will talk about halo textures and cookies and stuff in class, and then we'll talk about the other forms of light. So the only one here we really spent time with was this point light, but there's also spotlights. Obviously, there's directional lights, which have been shut off here. And now, like, I turned that back on. You see how, like, just bad that looks? I don't know. It just looks bad. This is so much, like, more elegant looking. More realistic, I guess. Yeah, so directional lights, point lights. We'll talk about spotlights and other things like that in class. And then how the skybox can interface with that. So yeah, I wanted to throw this out there. I'll obviously link this to you guys in class. This should probably be very similar to what we do in class, but if you need to reference a different way of thinking about this outside of the VOD from our Zoom class, hopefully this was useful for you. Yeah, so your homework also, just really quickly, will be to do something like this again. And again, from personal experience, man, like here I am before class, just walking through the entire process again. Because if you don't have a background in lighting, it's kind of weird. It's like cumbersome. And if you do something wrong, you click the wrong button, you uncheck a box or something, everything kind of breaks. So you want to go through it many, many times just to get used to it, comfortable with the process, so that when you're actually doing it in your game, in your scene, in your world, when you're making your VR stuff, it feels good, so that you can be creative, right? You're not just trying to make lighting. You want to make good lighting, or the lighting that you want. Does that make sense? So yeah, just let me know if you have questions. We'll obviously chat about this more in class.